All right, so in Algebra 2 and in Pre-Cal, we really do interval notation. But to kind of ease into interval notation, we're going to review inequality notation. And inequality notation you guys did in like elementary school. So this is an example of interval notation. Are the x's larger or smaller than -3, y'all? Yeah, x is greater than. Can I include -3 in the inequality statement? Is -3 part of that? It's not. If you guys remember, it would be part of it if it had a little line under it. So this is inequality notation. And then, y'all, there's something called set builder notation, which is that. And I don't know what this is used for. I have to quiz and test you on it. You're going to have to write it. All you have to remember is that it's just like inequality notation, but it has extra symbols. So if you notice, there's parentheses, or not parentheses, braces on the beginning and the end. There's an extra x. See the extra x right here? And that vertical line. But it means the same exact thing as that. Those are identical. So on Tuesday, if I ask you to write something in set builder notation, don't forget the two braces and the extra x with a vertical line. If I ask for straight inequality, then it's just that. Then we're going to talk about interval notation. This is the new stuff. This is really what we're going to focus on the rest of the year, and you guys are going to use this stuff like crazy in Pre-Cal. So in order to kind of introduce interval notation, we're going to go back to that original example. So if you find this in your packet, I don't know why I'm up here. It should be right here. We're going to take that first example. So here I go, kind of writing stuff that's not really in the packet. All right, so remember that example, x was less than and -3. So what I'm going to do is I'm going to translate that to a number line, sketch a number line under there, and then go ahead and write a -3. -3 is on the left side of the number line because it's negative. So I'm going to draw a -3 over here. Draw a little tick mark that goes with that -3. And then I'm going to circle it. I'm going to circle the tick mark. So I'm going to draw a big circle around this. And what I'm about to do is I'm about to make this number line match what that says. And remember, that is all of the x's need to be greater than -3. So if I'm working a problem, the only answers that would make the problem true are greater than -3. So I'm going to grab my highlighter. I use a highlighter to shade number lines just because it looks neater. I'm going to highlight where the numbers get bigger. Also, I'm going to draw an open circle around that -3. Like I can see through that circle and see the number line. Because remember, we're not including -3. So these two mean the same exact thing. Also, y'all, notice how I shaded the arrow. Arrows are so important in Algebra 2. We'll see why in a second. If this was a free response question, like on a test or something, and you guys just left it here, I couldn't give you full credit. So if you shade an arrow, make sure you exaggerate that shading so I can tell you did mean to include that. Any questions on how those mean the same thing? All right, cool. Let's talk about when it's a closed circle, when we fill in the circle. So I'm just going to make up, I don't know, something. Let's say, hold on a second. Yeah. Will y'all please write that down? So if you guys notice, the x is on the other side. Get comfortable with x being anywhere. In a minute, x is going to be in the middle of them. So don't try to like follow arrows or anything. I know some teachers taught that. Don't rely on that at all. You can rely on your second grade teacher telling you the alligator mouth wants to eat the bigger fish. So like for here, are my x's smaller or larger than a 5? Alright, so 5 is positive. Y'all draw a tick mark towards the right side because that's where the positive numbers are. Go ahead and draw your circle. And I'm going to shade in that circle. Why?
Because it's equal to.
Yeah, because it has that line. So when you guys see that line, shade it in because we want 5. Shade it in pretty good where we cannot see through it, like a brick wall. You cannot see through it. And then shade where the x's get lower, which is going to be to the left. So let me grab my highlighter here, and we're going to shade this. So these match over here on the right side. These two match over here on the left side. Now, let's just talk about interval notation. Just dive off the deep end. Interval notation kind of looks like an ordered pair, but it's not. It's not a point on a graph. It represents a range or a domain of stuff. And the way that you write interval notation is you look at the number line and you read it just like a sentence from left to right. So right here, I'm starting on the left side, and with my eyeballs, I'm scanning the number line, and I start seeing some shading. The shading begins on that number. What is that number? So right underneath that, a -3. So I'm going to write a -3. And remember, I said it kind of looks like an ordered pair, so I'm going to draw a comment, because I'm going to put something else there. But I don't know what I'm going to put there. I got to go back to the number line. So that's where the shading started. So I'm moving my eyes. There's where it stops, but what's the last thing shaded here? Infinity. How did you know it was infinity?
It keeps going as an arrow.
Arrow. Y'all, arrows are so important in algebra too. That's why I said make sure you shade the arrow if that's part of the answer. Anytime you see a shaded arrow, you're always going to have an infinity symbol. That shaded arrow is on the right side, so I know it's positive infinity. So the best you can, draw an infinity symbol. It's a sideways 8. Now we got to go back and put some symbols around it. So for interval notation, see how this is not part equal? And see how we drew an open circle? The way that we show an open circle on interval notation is a parenthesis. So draw a parenthesis right here. That lets me know that's an open circle. That lets me know it's not part equal. Over on the flip side, can you guys ever equal infinity? What number is infinity? It doesn't exist. There's no way we can ever have part equal. So a parenthesis always goes with an infinity symbol. Anytime you draw an infinity symbol, it can never ever be part equal. It always has a parenthesis next to it. So all of this means the same thing. So let's go ahead and look on the other side of the page when you have a closed circle. So we're going to write this in interval notation. And remember, I read it like a sentence from left to right. So I'm starting here on the left. The first thing I land on is a shaded arrow on the left. Shaded arrow. But that's not positive infinity. What is this?
Negative.
It's negative infinity. And remember, you can never equal infinity. You can't equal negative infinity either. So this is going to start with a parenthesis and draw the negative infinity symbol. Remember, it's kind of like an ordered pair, so draw a comma. And then go back and keep scanning. And I'm scanning, I'm scanning, I'm scanning. Here's where the graph stops. Here's where the shading stops. It stops on a 5, so I'm going to draw a 5. But I can't see through it. I shaded the 5 in. It's a closed circle, because remember it was part equal. In interval notation, to show that it's part equal, y'all draw a bracket like this. That's a closed circle. That lets me know it's a closed circle. That's it. That's all there is to interval notation. So we're going to take this concept and do a few things with it. All right, so remember, I told y'all yesterday I wasn't so hot in math, so I made up some tricks to help me memorize stuff. I'll share it with you. If you like it, great. If you think it's silly, then you can just delete it from your mind. Here's how I remember what goes what with interval notation. Remember over here, I don't know if y'all paid attention or not, but I was like, can I see through that circle? Can I see the number line? Yes, I can. Can I see through this? No, it's closed off. It's colored in. I cannot see. It's like a brick wall. I said that stuff on purpose because that's how it helps me memorize it. So, remember, if you cannot see through bricks, first of all, what does bricks start with? What letter does bricks start with? What do brackets start with? So it kind of helped me remember if it's like a brick wall, and these even kind of look like little brackets to me. So remember, closed circle, it's a bracket. You cannot see through it. If I can see through it, the sideways profile of an eye, this kind of looks like parentheses to me. So if it was open, I remembered that it was parentheses. That just saved me from having to look back at my notes. So if it helps you, that's awesome. If you think it's silly, then stop looking at it. All right, so let's go ahead and talk about what we did in words. So when do you use brackets on interval notation?
When it's a closed circle.
When it's a closed circle, let's write that. And we can write something else here. Think about the inequality symbols. What do the inequality symbols have to have for it to be a closed circle? What has to be underneath it? Yeah. Let's draw examples of that. All of those, all of that goes together. So on the flip side, what gets parentheses? What's opposite of closed? Circle. Circle. And what are the inequality signs missing on that one? What is not going to be underneath it? The line. Yeah. So y'all just draw some inequality symbols, just plain ones. There's something else on this side. Think about what we just did. Infinity. How did you know to draw infinity? What's always shaded with infinity? The arrows. Arrows are so important. We drew arrows. We drew parentheses. So, when do you use parentheses? When it's an open circle, when it's not part equal, or when the arrows are shaded. I'm going to write shaded arrows. And remember, shaded arrows just means infinity. So that's when you use that. So, all right. It's not always going to look like that. Y'all did that in like 2nd or 3rd grade. So you're in a big class. We're going to amp it up a little. So not only do we have regular inequalities, we have compound inequalities. And they're not tough as long as you take good notes on it. So I'm going to make it as easy as I can. So for compound inequalities, there's only 2 kinds, y'all. There's an and, then there's or. That's it. The and statement, sometimes the x is in between. Remember I told you it was going to be stuck in the middle in a minute. There it is. The x is in between 2 numbers. Notice you have 2 inequality symbols. I know that's an and statement. I could also use this symbol right here. So, this is -4 is less than x. So that means x is greater than -4. And now I'm going to write the left side of that. So I'm going to cover this part up. X is less than a 4. Those two mean the same exact thing. I might write that either way on a test or a quiz. You might see it stuck in the middle. You might see that weird upside down looking U. I might also even use the word and. So I could also write just the word and. So looking at this part right here, this is x greater than a -4. So I could write that left part, write the word and then I'll write the right side, which is x is less than a 4. All of those are going to have the same exact answer. I will write it any different way. You just have to memorize it. So remember, interval notation is like our end game here. So I might give you that, but I really want to know what that is in interval notation. The way that we're going to do that is we're going to use a graph. Sometimes you have to graph it. Sometimes you don't have to graph it on a test or quiz. But I would graph it because it helps me minimize mistakes. It's easy to sketch a graph on the side of a paper. So I don't know if you guys noticed or not, but up here I wrote the word across. Notice it starts with the letter A, like and. The shading has to go across on each other. Like one's going that way, the other one's going across on top of it. It has to overlap. So what this is saying, whatever problem I was working on, I only need numbers that are greater than -4 and less than a +4. So like 3. 3 is going to be part of the answer. 2 is going to be part of the answer. What about -5? Is -5 going to be part of it? Because it is not greater than -4. What about a +5? Is a +5 going to work?
Yes.
Is it? Oh, whoops, I don't know what happened. Thank you. It's so sensitive, guys. So sorry. Will 5 work according to that part? X is less than 4? Oh, is 5 going to fit that? So here's how we're going to do this, guys. I'm going to go ahead and draw a +4 and a -4. I'm going to draw some circles around it because it's always got circles on it. And then I'm going to go back and think, do I need to color any of those in? Do I? Or any of those closed circles? Neither one of them have an underline in between it. So let me go to this equation or this part over here on the left side. I'm going to cover this up for a second. So what that's telling me for this -4, I want my x's to be greater. So if that was the only inequality, like a second grade problem, I would shade that way. But I'm not shading yet because that's not all the problem. If that's all it said, I would shade that way, box in my answer, move on. But that's not all it says. It also has a piece over here. At the same time, x has to be less than 4. So over here at the +4, if that was the only piece I had, I would shade that way. Where the arrows are pointing in, that's where they would crisscross and overlap and be across from each other. That's going to be the answer to that problem. So what's in between? What's in between? Perfect way of putting it. What's in between? Let me get my highlighter. I'm going to highlight in the middle. %99 of the time, your and statements are going to be a line segment. So that's going to be the answer to this. Now I'm about to write that in interval notation. Y'all, did we shade an arrow on this? Did I shade these arrows? No infinity symbols. The only time you write infinity is if you have a shaded arrow. So I'm just going to have plain numbers. What numbers am I going to have? I don't know. What did I circle? A -4 and a +4. Can you see through that? So do I put a bracket or a parenthesis? It's going to look like an ordered pair, but it's not an ordered pair. So I can see through that. It starts at the -4, and it goes all the way and stops at a +4. So I'm going to write the number where it stops, +4. No, don't forget your comma. I see through it, so I'm going to wrap it up with a parenthesis. That is an and statement. It's like a 2-for-1. You really have to look at each piece individually. So look at the left side, then look at the right side, and then see what's in between, see where it overlaps. That's how you're going to work that. So that's an and. Here's an or. An or can be anything. Anything that you shaded is part of the problem. It doesn't have to overlap. Anything that can be it, That's going to be part of what we want. So, only two ways I can write this. I can write it, of course, with the word or the symbol turned right side up. So it could look like that, which is already printed. Or I can drop the word and replace that weird looking U, which stands for union. Both of those mean the same thing. I will quiz or test you on each one. You have to know what each one means. Same thing. Okay, y'all, and just like the other problem, I'm going to take it piece by piece. Look at the right side, look at the left side. So over there on the left side, it says x needs to be less than 7. So what are numbers less than 7? 6. What about negative 500? Or x is less than negative 2. Either one, not both. So over here on the positive 7, it's not part equal, so we can't include 7. If that was the only thing on here, I would draw an open circle. By the way, when you draw open circles, train your brain to automatically think about a parenthesis. And all the numbers less than, including that arrow, would be the first part. For the second part, it also could be less than negative 2. Y'all, negative numbers, you know this, are over here on the left side. So I'm just going to kind of estimate where negative 2 would be. It's an open circle. And if that was the only thing, then I would draw an open circle and shade it. Anything you shade is part of the answer. So when we go to write this in interval notation, you read it like a sentence. Start from the left, go to the right. So over here on the left, the first thing I see is an arrow. You're going to have infinity in your answer. Right. And it's a parenthesis. Don't draw a bracket. So the first thing I'm going to write is my negative infinity. And I'm going to draw everything that's shaded. Y'all, the negative 2. Can I see through it? I got some pink highlighter in it. It's not open. It's closed now. That closed it right there. So this is actually shaded. It's continuously shaded until the 7. So even though there was a negative 2 in the problem, it's not even part of our answer in interval notation. It's shaded. It's part of the solution. The solution stops at positive 7. So draw a comma, write positive 7. And then what kind of symbol finishes that? It's parentheses because we can see through it. All right, so if this, and remember it, chances are it won't be. If that wasn't there on Tuesday, how would you know that's an and statement? How do I know it's and?
You told me.
Yeah, you can't answer. Because it's in the middle. Perfect answer. That's right. In between, that's an and. Good job. All right, so I know it's an and. I'm going to draw a negative 3. I'm going to draw 2. Okay. And then I'm going to draw some circles around them because that's always the process. And then one of them shaded in. Which one's shaded in?
2.
Yeah. All right. Remember, it's a brick wall. You can't see through it. Okay. So if this was the only thing, so I'll just cover that up for a second. If that was the only thing that was there, would I want my x's to be larger or smaller than the negative 3? Larger. It says x is greater than. So if that was the only thing, I would shade that way because that's where the x's get bigger. But it's not the only thing because we have this other side. And this other side, x is less than or equal to it too. So if that was the only thing, I'd shade less than towards the left. Oh man. Which is going to be that way. see how the shading's going to crisscross on each other right here? They both point in. So I'm going to go ahead and pull up my highlighter. This is what it's going to look like. And then my interval notation is not going to have parentheses. I'm sorry, it's not going to have infinity. It is going to have parentheses. I can see through it. Can't see through that. There's my eyeball, there's my brick wall. What do I see through? I see where the -3 is. What do I not see through? -2 is. Does anybody have that? Anybody have 11? Cool, good, alright, awesome. That's it. Number 2. Number 2 real quick, that's a baby problem. There's one inequality symbol. If there's only one inequality symbol, chances are you're going to shade an arrow. Chances are you're going to have infinity in your answer. So, set builder, blah, blah, blah. Don't worry about the extra stuff. That's just x is less than a 2. 2 is a positive number. Open circle. I want my x's to be less than. That is -infinity to a 2. Everything gets parentheses. Nothing's part equal. Pretty basic. This next one, not so basic. Y'all, that stands for all real numbers. Like anything. Like an equation like this. Can you put anything in for x and it'll be a true number sentence?
Yep.
So how do I show that on a number line?
You just highlight the color.
How many arrows did I highlight? 2. That's how many infinity symbols I have to have. How many arrows? That's how many infinity symbols we have to have. So, if you notice, this starts at -infinity, and it's shaded continuously to where? Positive infinity. You're going to use that all the time. You're going to say, I'm going to say, what's the range? You're going to say -infinity to positive infinity. What's the domain? -infinity to positive infinity. You're going to use that one a lot. Let's take a look at, one more thing. Just in case, y'all, you will also, like this fancy R, that means all real numbers too. Or you can write the word all real numbers, I don't care. But when it comes to interval notation, you have to write negative to positive infinity. Remember, never any brackets. Has to look like that. Number 4 is an or statement. Remember, anything you shade is going to be part of the answer. It doesn't have to overlap. This or statement is harder than the one that I just did earlier. So let's take a look at what this is. I'm going to break it down piece by piece. So I'm just going to cover up that for a second. And I'm just going to focus on x being less than or equal to a -2. So I'm going to draw a -2 over here on the left side. Draw a circle. Looks like I'm going to be coloring this in. And I want all the values less than that. So y'all, I'm about to shade the -infinity arrow. And remember, that was shaded in. Okay, now let's look at the other side. The other side is that. And x is greater than a 5. Okay, let me go draw a 5 over there. And open circle. And I want values that are greater, so I'm about to shade positive infinity, because I'm going to shade the arrow. Open circle. Okay. Again, y'all, how many arrows did I shade? 2. I have to have that many inequalities or infinity signs. But is my answer going to look like what I did here? Because I shaded all of that. But do we have a gap here? So you're going to have like 2 pieces And that'll happen sometimes with or statements. Here's how this is going to look. Still, you read it like a sentence from left to right. Starting on the left, what's the first thing I see? A negative arrow. So start with negative infinity. Remember, infinity always has parentheses. I'm going to draw a comma.
Well, did you put a bracket right there?
Right here. For infinity? Do we equal infinity?
Oh, no.
But a bracket's coming. The bracket goes with 2. So, I'm sorry, -2. That one gets a bracket. Guys, we got to close that off. He's right. The bracket's there. It goes next to -2. You got to hop over the unshaded part. So, to get back there, what kind of statement was this? This is an or statement. Write the word or. Write the word or write the weird-looking U. Or that thing. And then pick up where you left off. Where does shading happen again? 5. But don't draw 5. What do you draw first? Yeah, because I see through it. And then that goes all the way. If you got your pencil bag out, like I would highlight that. If you just have a pencil or whatever, I would draw a star around that problem. That one's pretty important. Pretty important for sure. We're almost done, y'all. Y'all are doing great. I know it stinks to sit here the last class period. I'll just work this one. If you just want to watch me, I'll do all the work. It's cool. Notice, this is almost the same exact thing. What's different? The and. Watch what happens when I try to draw the and. It's the same. So like, oh, come on. So, here's -2, closed. Here's your 5, open. Is anything overlapping? It's an and. You have to have crisscrossing happen. Is there anything happening here? No. So guys, you're going to write no solution. If it's an and, no solution. There is no such number that's less than -2 and greater than a 5 at the same exact time. If you're lazy like I am, you can just draw that. Do y'all remember what that means? Yeah, well, we call it empty set. You can just write that. That's cool. That means no solution. Last thing I'm going to talk about. I'm just talking about these 2 rows, and then your day is over. This is it. So, for these 2 rows where the interval notation is given, we need to talk about how you're going to write back what it was, because you're going to get tested and quizzed on it. So, on this row right here, first of all, do you see an infinity symbol? No. No. So, if I shade this number line, I'm not shading an arrow on this. Do you see the infinity symbol here? Yes. Which arrow is going to be shaded, the right or the left? The left one. Let's go back up to this row. I'm going to start with the number line because it's easier to write the inequality. So over here on the number line, I'm going to draw a -4 and a 7. Spread them out a little bit. Draw circles around them. Which one do I shade in like a brick wall?
The negative.
The -4 because it has the bracket. The bracket's right next to it. So this interval notation says we want all the numbers in between -4 and 7. So when I grab my highlighter, it's going to look like this. That's a line segment. That's an and statement. So over here, I'm not going to do set builder because we don't have time. But your setup for an and statement is always going to be that. Your signs are always going to be pointed that way. You might have to go back and tweak it, which I need to tweak it. If you notice the 4 is filled in on the low side, then on the low side on the left, I have to draw a line under it. Where does the shading start on the left side? What kind of 4? -4. Where does the shading end? That's all I have time for. So listen, I'm going to ask y'all to do some background. Please do the best you can. Please circle those 5 problems. That's going in the grade book tomorrow. I'll check it in class. You can do more if you want. Anything in the packet's fair game for a test or a quiz. But since you just sat through all that, I tried to shorten it as much as I could.